Alright class, in this video we're going to talk about basically the functions you should already know. So I call this the library of functions section, and this will be part 1. Alright, so in this part we're going to talk about all the power functions. So, focus. We're going to be talking about functions x to the n, okay? So to start our power functions, we'll start with the ones we know the best. So we'll start with even positive integers. Okay, so like 2, 4, 6, 8, who do we appreciate? Okay, so this would be like f of x equals x squared. Okay, now we all know that's a parabola. So alright, there are 3 important points on this. So if I plug in 0, I get 0. If I plug in 1, I get 1. And if I plug in negative 1 squared is also 1. Okay, when we're asking for you to sketch these things, the important points are ones we want to know, and these are the important points. You don't need to sketch more of them. Okay, so my parabola is going to do something like this. Okay, now it's interesting to note what happens if it's something different. So this is my graph of x squared. So how about x to the 4th? How would that compare? Well, if I were to plug a number into, so let's see, I'm going to say g of x is x to the 4th. If I were to plug 2 into that, I would get 16, much larger than 2 being plugged into x squared. So between 1 and infinity, x to the 4th is a much larger function. But if I plug 1/2 in, 1/2 squared is 1/4, 1/2 to the 4th is 1/16. So x to the 4th would kind of fit in. It would otherwise have the same values, same important points. Okay, so I'm kind of exaggerating things here, but x to the 4th would kind of fit in here like this. Okay, it's important that you note how they compare to each other. By the way, x to the 4th, you may look at it and say, oh, it's a parabola. It's not a parabola because parabolic distances are measured in Euclidean form, which involves square roots and squares. Okay, so that's an even positive integer. How about an odd positive integer? Okay, so let's say x cubed. So what does x cubed look like? Well, it's still going to have the point 0, 0 and the point 1, 1. When I plug in negative 1, however, negative 1 cubed is negative 1. And all of the odd power functions like this, they're all going to go through those 3 points. Okay? On the right-hand side, it looks kind of like a parabola. And on the left-hand side, it looks like a parabola pointing down. And this would be x cubed. Once again, if we drew x to the 5th, it would be smaller between 0 and 1, larger technically, but, you know, absolute value-wise not, between 0 and negative 1. And then it would be larger than x cubed from 1 to infinity, smaller than x cubed from negative 1 to negative infinity to negative 1. Okay, what else could we possibly look at? We could look at the reciprocal functions. So, n equal to an odd negative integer. Okay, so let me move that up here. So an odd negative integer, so this would be like n equals negative 1. So f of x equals x to the negative 1, which we know as another form would be 1 over x. So once again, there's an odd and an even version of this. So 1 over x has a specific kind of thing that we want to talk. We've already talked about domain. So if you substitute x equals 0 in, you're going to have division by 0. So there is a vertical asymptote at x equals 0. So 0 is not in the domain. I should write that here. Domain of f, x is not 0. Okay. We also, if x gets really large, 1 over a really large number is teeny tiny number. So that means we have a horizontal asymptote of y equals 0. Okay, so clearly we can't plug the point 0 in, but we can plug 1 in and we get 1, and we can plug negative 1 in and we get negative 1. And then it just has to fit in between those asymptotes. So we get a curve that looks like that. Okay, and 1 over x cubed would be very similar, 1 over x to the 5th, and so forth and so on. Okay, so if n is equal to an even negative integer, so we're going to say maybe 1 over x squared, or x to the negative 2. All the features we had over here are still the same. So we still have a vertical asymptote of x equals 0. By the way, we don't say 0 is an asymptote. An asymptote is an equation. So the horizontal asymptote here would be y equals 0. If you tell me 0 is an asymptote, I'm going to count off points. All right. If you plug 1 in, you get 1. If you plug negative 1 in, though, you get 1 as well. So it's kind of like the negative component of this graph gets flipped up. Okay? So filling in between the asymptotes, we get something that looks like that. Okay? And then the other power functions, I have to try to fit them all in this space I got left. So these would be the root functions. So let's just say we got n equals 1 over k, where k equals 2, 4, 6, so forth, an even number. Okay, so this would be your x to the 1/2, which is also, we also rewrite that as the square root of x. Okay, so what does that one look like? Well, from our discussion on domain that we've already had, the domain of f would be x is bigger than or equal to 0. So we only have a right-hand side to look at. And if you plug in 1, you get 1. Okay, but instead of bending up like x squared did, it's going to kind of bend in a different direction. So it's going to have to bend like this. So that's what the square root function looks like. And let's say if k is 3, 5, 7, and I'll even maybe say even a little bit more there. So this would be f of x equals x to the 1/3. So what's the difference here? The domain is all real numbers. That's the cube root of x. Cube roots don't have a problem. Okay? So it's gonna have 1, 1 on it. And you may have figured out it's gonna have -1, -1 on it. But other than that, it's going to look like this guy with the part that's kind of below, and it's going to also have 0, 0. I should have pointed that out. So it's going to look like this. And it does have a feature here in the middle that I should have drawn this in a way to exaggerate it. This looks more like arctan. But it has this feature in the middle where it kind of goes vertical at one particular point. Now, to step back and talk about other types like this, if you'd have x to the 3/5 or x to the 7/9, it would also look like this. Notice if you have an odd power over an odd power. So the interesting things are ones where it's an even power over an odd power. And so the last one I'll mention is x to the 2/3. So this is the cube root of x, whole thing squared. That's at least one way to write it. Okay? And it's going to have the domain of all real numbers because the cube root comes first. So it's going to have 0, 0 and 1, 1 on it. And it's going to look like this over here. But this is where I start talking about your pictures that you drew in kindergarten. And what did you always have in your picture? And you had the sun, you had mommy and daddy, you had a house and a tree, maybe a dog, maybe something else, clouds in the sky. But you had the kindergarten bird, right? And the kindergarten bird looked like that. Because if I plug -1 in, the cube root of -1 is -1, but when I square it, it becomes positive. So these two graphs actually have something very important. This one has what we call a vertical tangent at 0. This one also has a vertical tangent, but it's what we call in addition a cusp.